I'm Joe Ryan, and a little bit about myself. Although I've got a gray beard, I only started a professional IT career about 9 years ago. I flew for the Army for 24 years, and then I decided, yes, that's what I'm going to do next is join the IT crowd. I'm a system administrator for the Institute for Cyber-Enabled Research at Michigan State University. And I've only been on that team for about 4 years now, since 2020, 2021. You can see where my email is if you'd like. I'm going to give you a brief overview of high-performance computing at Michigan State University, so people that aren't familiar with it kind of get an idea of where the workload is in the change in workloads for what people would do. We'll talk about some constraints, how we evaluated our OS, our operating system options, what we did to do our software deployment, the rollout plan we used to migrate every system, some of those challenges we encountered along the way, and then a little bit about what we think were the successes of our operating system upgrade. So high performance computing, it is a batch processing system where users submit batch jobs, which then get run on all of the nodes of the system. We do use Slurm as our batch scheduler. We've got 3,000 users across the university departments, including students, faculty, and staff. We run about 1,000 to 1,100 nodes with about 615 GPUs on them. Those numbers are a little off because we dropped off. Yes?
I was just going to ask, are these PowerPoints going to be available after the presentation?
Yes, they should be.
Okay.
Or the video is recorded so that you could review them later. I don't know if they publish the slides with the recording, but I will ask.
Thank you.
And so we run a large number of compute nodes, hardware devices, with a large number of GPUs. We've got a large memory footprint and storage. Currently, I think we're up to about 10 petaflops. But we had 4 as of 2014 when that slide was made. So it's a large environment of computers with a large range of users and use cases for scientific computing to do research. So with that number of users and students, faculty, and staff, that leads us over to some of our constraints. We, at the time, were running more than 6 generations of computing nodes, ranging from 2014 all the way through 2023 when we picked up a couple of Grace Hopper NVIDIA GPU nodes. Our oldest hardware at the time was still providing useful user services, so we were still using it actively at the time. We couldn't just decommission it. We had a local software stack of about 1,000 software versions and different tool chains that were available to the users to load on demand. Things like GCC, Python versions, R versions, specialty things like AlphaFold for, forget what they do, genomic analysis and biochem. There was the upcoming CentOS 7 release date, or end-of-life date, that was kind of pushing us toward we need to do something. We had to do something coming forward. We did need to deploy it with our current tooling, which we were running XCAD, Extreme Cloud Administration Toolkit. It's just a way to provision bare metal machines. It's what everybody on the team had a lot of knowledge in. We did want to manage it with our current configuration management system, so we were using Puppet, and we wanted to continue to use that to build on the knowledge that we had from running Puppet for 10 years. And then we had to look at the available time that we had and our team knowledge base, and what can we learn in this short amount of time, and what do we have to go, that's a bridge too far. So we started to look at operating systems and what were possibilities and what were kind of unreasonables. And I say unreasonable, but it was just we quickly ruled them out is more the definition. They weren't unreasonable per se, but they were things we want to rule out early because we can't test everything. We have to pick the narrow range of things that we're going to test, and we're going to pick one of these options. So Arch, Gen 2, NixOS could have been used. They're great tools. But we didn't feel like their maintenance overhead and team knowledge base that we had would support deploying any of those 3. Arch, obviously, it's continually increasing packages, and NixOS would have been a whole nother thing to learn to manage the infrastructure. So we quickly ruled them out. Same thing with SUSE Linux Enterprise and OpenSUSE. We didn't feel we had the team knowledge, and our tooling wasn't really set up for that. We were running CentOS, so something similar to either a Red Hat Enterprise Linux or another one that people on the team were more familiar with would have worked better. And then there's a pretty low adoption of the SUSE Linux in US high-performance computing environments. There's a lot of it in Europe. They're using a lot more over there. But in the US, the people that we know, none of them were using that. So it makes it difficult to choose that as an option. We looked at CentOS Stream. We don't really have anybody doing any development on the Linux side. So we didn't feel that there was a lot of benefits for us to use it. If we had somebody who was like, yeah, I'm contributing on Tuesdays, we're doing any sort of contribution, I think some of us would have argued more in favor of it. There were people that had started using it and didn't have a good initial experience. And then there was some additional work we'd have had to done to take those, I forget what they called them, but where they make a release and to kind of pin those versions, all the versions of the packages, to just have that and repeating that if we needed to restart the cluster. How can we get that exact version of packages that we had already been running? So for those reasons, we kind of quickly ruled that out. And then container systems, we have a lot of user-compiled software. People are writing their own software using the tool chains. Can't really insist that everybody uses a container. We have some container availability, but we couldn't really insist that they had them. So that left us with the Red Hat Enterprise Linux 9 and the clones. And we also had Debian and Ubuntu that we felt we could evaluate more thoroughly. We kind of looked at the whole team, discussed it, and we had a lot of conversations. And then we also sent out a survey to both our researchers. We have research consultants on the team who speak the research language, and then the sysadmins, and we all came together and had conversations. We did survey the team as a whole to get unclouded opinions that you could get anonymous opinions about what it was and what your options, what you thought was the best option, if there were any blockers you had, or your concerns with moving forward with any particular version. We found out that Alma wasn't currently supported on the OS deployment tooling, XCAT, so we couldn't use Alma and use our current deploying tool, so we would have had to learn something new there. Every one of the Enterprise Linux 9 clones and Red Hat Enterprise Linux did not support the older hardware that we had from 2014 and 2016. We tried to run it as long as possible, and if we had dropped that versions of our systems, we would have lost about 30% of our compute capacity on day one when we switched over to the new operating system. We tried some workarounds of rebuilding those tools manually using their source code, but they really were looking for the wrong libraries, and we didn't want to have to patch the libraries provided with the OS just to support that older hardware, because we did know that in 12 months to a year, or 12 months to a year and a half, that we were going to start retiring some of those systems. Yes?
Just note, I believe that with Alma Linux specifically, that has changed. They now support older hardware.
And at the time, that was a concern. And so all of these are point-in-time considerations that we had. And I think they're also supported on the XCAT tooling now. But at the time, it wasn't written. We would have had to done that work ourselves.
Can you just confirm, what was the rough date when these decisions?
So we started looking at this in, let me see if I've got a date written down. We started looking in early 2023 was when we started to kind of think about where we were going, because the June of 2024 end of life date for CentOS, we wanted to start looking and evaluating these things a year out. And so we kind of settled on the operating system we were going to use in December of 2023. And even some of these early assessments, they might have come out in December of 2023, but by then we had already made our analysis and we weren't ready to go back. So that's kind of a timing. That has changed, along with a couple other things that I'll point out. So they probably do support that older hardware now, and I expect they're supported on XCAT now, or at least the XCAT version that's being run. And then we determined that we didn't like the extra step of management for Red Hat Enterprise Linux. There was a license available for us at the university, but we would have had to interface with another team on campus to provide us those licenses and do the management. And they were running the licensed server, and we wouldn't have been able to run the licensed server ourselves. And even if we did, we've had to do the work to manage the licensed server. And so for those reasons, we kind of went, well, that's a mark against them in that column. We looked at the Debian cadence, and there are organizations on campus that run Debian, and a lot of us had Debian experience, but we didn't think we wanted to deal with that cadence of releases. It wasn't as regular of a cadence, and it seemed a little too short for us. We always felt like we were behind the curve in the other department working with Debian. And we weren't developing in Debian either, so we didn't really have any contribution for that. The Ubuntu life cycle, 5 years seemed acceptable. If somebody decided that we couldn't do something, well, there's the option we could have paid for extra length. It was supported on our deployment tooling with some caveats that I'll bring up later. We had a bunch of Debian derivative experience. We had 4 or 5 people that had been running Debian in production on campus for 10 or 15 years prior. And then older hardware was supported out of the box. They had a lot of the drivers were in tree. You just installed Ubuntu, and then that older hardware was operational. We didn't even have to go and get the NVIDIA drivers for Mellanox cards to run the InfiniBand, which that's really the hardware that was the problem, was the high-speed interconnect networking. Those drivers weren't available because NVIDIA was not writing them for it. So that was kind of the stumbling block. As our software deployment, we were previously using EasyBuild, which is a way to recipe. It's sort of like a makefile, but it's more specialty designed around building software from source and distributing it. So we were using some EasyBuild recipes and a manual process. We always compiled for the least common architecture configuration so that it would run everywhere. And then we distribute it with network share and the CERN virtual machine file system, which is a HTTP-based file distribution system using local caching. I'd like to do a whole talk on that, but that'd take too long. So we were already using those 2 tools to do our software distribution. And we wanted to optimize those installs for different architectures because we got brand new equipment. We've got brand new hardware, super advanced, Zen 3, Zen 4 systems. We really wanted to optimize for installs on a different architecture. We looked at the European environment for scientific software installation stack. It's available for use for anyone. As long as you have LMOD installed on your system, you can get a CERN VM FS client, and you can pull down that public software. It's all open source software that you can just module load. I want GCC 13.3, and you'll get that version from Easy. They use a Gen 2 prefix, but we found that if we set that as the default across our entire system, it would conflict with some local binaries. They have since fixed that, much like Alma and their hardware support. They've since fixed that, and they've got some better building tools now for building on top of that software, but at the time, it wasn't clear there was an acceptable path forward for building local software on top of that. They were using RPass for the linking libraries, and people would have to change how they compiled their software to change to RPass, and we didn't want to make our users have to change their workflows to introduce this RPath. And then, as I said, since then they've improved the tooling for building software on top of it, but at the time it was not available. So what we settled on was using a locally built Easy Stacks, which are the Easy Build recipes. You build a tool chain which includes Python, some version with the GCC compiler of some version. So we use the Easy Stacks with the same file structure as Easy. So we said, well, we really like how they laid that out. We're going to go ahead and use that exact same layout with the file folder structure so that it replicates it identically. It's just we're building it all locally. And then we use their initialization scripts but modify them for our environment so that we were the ones in control of how they got loaded and which ones would. We didn't use the RPass, so we didn't have to introduce that error. And then we continued to use the CERN VM file system. And in it, what we decided is if one of these easy build configurations didn't exist already, we would create it locally using the Easy framework and then contribute that upstream so that they could in turn try to incorporate that in the next version of Easy. Previously, we had done manual installs and left those, but we decided, nope, it's a hard line. We are not going to install it without an Easy Build script because we want to be able to build it for 6 different architectures without having to do that manually. So that's one of the things we settled on, is that's a hard line. The biggest thing was, how do we implement all this and give it to our users without telling them, hey, we got to shut down the system for 2 days, we got to rebuild the software on everything, we got to load operating systems on all the hardware. So what we decided is we would kind of do this phased migration plan. In 2023, December, we started our initial testing and software builds. And we did that for about 3 months, where our internal researchers could, who are doing their own research in addition to helping others, they could build the software. Phase 1 was all the stuff we absolutely knew we'd need to have on the system. And phase 2 was a survey of what software do you need as a community for us to build on the system. And so that was phase 1 and phase 2 for software. They were able to build that out, test it on their research, and then we started developing our documentation in that period. And then so in April of 2024, we started our early adopters. We migrated about 25% of the cluster, and it was opt-in. You could tell the scheduler that you wanted to use the new operating system. So it was opt-in. They could try it out. They could give us feedback. This is broken. I like this. It's missing this software. And that became our list of phase 3 software. Was as people started using it, they would tell us what they were now missing. Because we didn't just rebuild everything we had accumulated over 10 years of CentOS 7. We said, look, we know people are going to need these versions and these things. And so we built that, and then phase 3 listings got started when the early adopters were testing and telling us what they were missing. We left it at that stage for about a month or so. No, 2 months. And then in our main phase, we started in early June of 2024. And so we migrated about 75% of the general computer nodes and made it opt-out now. By default, you were going to get the new operating system. And if you really couldn't work on there, then you would choose to run on the legacy system. And so we switched from an opt-out to an opt-in, and on our number of jobs submitted, you could see that it went from all in the old system to all on the new system, because everybody by default went to the new system. And so we left about 25% of our cluster was not migrated. That was kind of the goal. We said, well, when we've got 75%, that'll be the start of this main phase. We have the concept of buy-in nodes where researchers can buy compute resources, and then we run them for them. So we had to coordinate the migration of theirs with each research department directly because they own the equipment. And we said, this is the date at which they will all be migrated. However, if you want to do it early, let us know, and we will schedule on your schedule in this 3-4 week period before that end date. And so we started doing all the buy-in nodes started almost the day after we finished all the general nodes, because people had said, I want it as early as possible. And we kind of settled them out throughout the next month so that by the end of June, mid-July, everything had been upgraded for the main phase. One thing we did in the main phase was we changed some scheduler tooling so that they didn't have to, if they put the reservation for the new OS and they no longer needed it, we'd strip it off automatically and just report to them, hey, you don't have to do this anymore, but your job started. So that it was seamless to them. If they had started using the new operating system, it was seamless to them. It continued to run on it, just stripped off the needed details and gave them a notice that, hey, you don't need to do that anymore, you're good. Let's see, and then, so that brought us to a late adopter phase. And we know that there's some late adopters, so we said, well, we'll leave a couple of each type of node on the old legacy system for a little while longer. So we did that, and then by the early August, we migrated all of those as well. So they had another short 2-week period where they could access the legacy OS directly. But that leads into the final phase, and so we created a legacy container where they had access to all the old software that we had built under CentOS 7, and it was running a CentOS 7 in a container. And so they could continue to run their research the same way they had before. It just spun up a container on the new operating system. And we're still running that right now just to support them as they transition. And at some point we will go no more, and we'll close that down and no longer have support for that, because we're running the infrastructure for the older software to be distributed to them. So that is one thing that we have to run in order for them to run those legacy containers. So at some point we'll tell them that there's no more legacy containers. Some of the challenges we found were package naming consistencies between the two different operating systems. We decided on Ubuntu, and at that point now we had to decide, okay, how are we going to install it? Well, this package isn't called that there, it's called this over here. So there's a little bit of work involved in changing that stuff and finding each of those things. They Ubuntu released a new Ubiquity installer in April of 2024, right as we were really getting started. And that did have some issues with XCAT that we had to work through. We using a custom partition that's part of that installer. It was designed to read in XCAT from one location, but we made changes to that file and it wasn't reading them. So we had to figure out where it was actually getting its partition scheme from and go in and change that. And every time it updated, we had to redo the changes. So that was kind of an issue with finding out where is that. It was supposed to do it here, but it isn't, so we had to troubleshoot where it was doing it. We run virtual desktops for users because some people like to use a GUI tool like RStudio and Jupyter Notebooks or just a generic Linux desktop. So our tool of Open On Demand, some of the stability we had to work through, there were some power management issues because by default a lot of that power management stuff was turned on in Ubuntu. And then because we're loading the desktop software but not running it on every system, we found some screensaver issues. We did have to go back, pull back ports from 2004 for some of the Xorg libraries. And I'm not sure where we're going to go with Wayland on the next version. I'm hoping that our Open On Demand tooling, they change over to Wayland because that is coming. We all know it. So we're hoping to see some of that change with the next version. We realized that the environments were passing through to the scheduler, so you had to submit from a control node that was running on the same operating system as the compute nodes. So all of our login nodes had to change to the new OS at the same time, and we had to ensure that they didn't submit to the wrong type of a node from that login node. So we did some scheduler logic to go, well, if you're submitting from this node, it has to be to this reservation that's the legacy OS. If you're submitting from the newest nodes, then it has to be to the primary partition that has the current operating system. And then finally, we did have a lot of technical debt. One of the joys of having 10 years of experience in Puppet was we had 10 years of experience, but we also had 10 years of technical debt in Puppet from people doing things the way they felt would get the job done today, but not really thinking about 10 years from now. We're going to have to do some of these things to fix that code base later. So that was a significant issue, but I think that it did help us in some of our successes. So one of the successes was our Easy Build Easy Stacks. So we're now distributing software that is optimized for the architecture of the device instead of just the least common denominator. So now when they're running on the 2024 cluster, which has brand new Zen 4 CPUs and H200 GPUs, they'll actually get optimized software for that architecture. We do have a generic one, so the first thing we do is build it for generic, which should run everywhere, but that's the lowest common denominator. And then we'll go through and run the builds for all the other systems. Our phase migration plan, I feel like it was a real success because we got some early people on there that were able to test it out and identify problems that we then incorporated into some robust documentation where we listed out known issues, some FAQs, and we really advertised the change and where you could go to find out how do I migrate my code to the new operating system? Where are the modules that are now available? So we now have a list of all the software that's available that's updated every time a build runs so they can quickly see is what I want and what version available. Some of that slurm submit logic really made it easy for the researchers to change over. They didn't have to remember or just get rejected jobs when they put in the reservation or didn't put in the reservation, depending on what they were trying to do, whether it was in the opt-in phase or the opt-out phase. We just stripped off what didn't need to be there and give them a notice, but make the job run where it was going to succeed. Finally, the team knowledge of that configuration management system and deployment tools, when we did identify a problem, we were able to quickly kind of identify, okay, where is this and what do we need to do to fix it? So that was really helpful because we had all that experience on board. We have a range of experience from the person who first started the cluster 20 years ago is still on staff, all the way up through our most recent acquisition had been there a year. And then that work on our configuration management system has made us more comfortable and ready to migrate to a future release or even another alternative operating system. Some of the when we decided we had to do this, we made a concerted effort to go, we're no longer just going to do, well, if it's this operating system, do this. We want to actually have a failure mode that provides a usable error message and doesn't cause the configuration management system to just reject the application. So now, instead of saying failed for this, failed for that, and then the next time you run it because Puppet doesn't order things, it would be a different failure. Now it will apply the things it can apply that it knows how to do. And if nothing's been written for that specific operating system and version, we just print out a message. That's not implemented for this OS. And tell us, okay, here's the list of things you aren't implemented. Now we can just create a JIRA card with all those things listed in it, and then we'll go through and we'll fix those things. So it made us ready to migrate to those newer operating systems on a better cadence. We also did a review afterwards of the community about how did it go and what did you see as the problems, and it was a very well received upgrade by the community that had been there compared to past operating system refreshes. So that brings us to, I'll leave you with some links to our site, documentation for CERN virtual machine file system, if anybody's interested. I'm happy to talk about any of those. I don't really know a lot of information on EasyBuild, but I'll talk about any of them for hours on end. Our documentation is open to the public. It is actually docs.icer.msu.edu, but you can get there from the ICER main webpage. There's a link to our documentation. A lot of people in the community have found it very helpful, even outside of our university. So I always point people to that when they're like, well, what do you do? And how would you do that? I point them to our documentation, and there's a lot of information in there. And we try to keep it well updated. Final thoughts. I don't think people should be concerned with switching to a new operating system. And, you know, they shouldn't see that as a really heavy lift. I think it can be done. We have no problem evaluating when we go to our next operating system, going, well, maybe we want to use CentOS Stream now because we feel like we've done the hard work to, it's just another operating system. We'll go ahead. It's like a major upgrade. No big deal. Even if it's a different operating system, we've kind of seen that, there are things you have to do and ways to move it, but you can even transition to an entirely different operating system. Thank you for coming.